So let's finish the lesson. We are right here where we've looked up on the vapor pressure table and saw that boiling point at the top of Mount Everest would only be 70 degrees Celsius. Now that's really an important thing, especially when you're at high elevation, regardless of what elevation you're at, even in the Rockies where it's, 8 or 9,000 feet, you can be 70, 60 kilopascals. And at that point, if you go across, water is boiling like 80, 85 degrees Celsius. So that really does impact cooking. And so I'd like you to think about what people might do, because if water boils at this lower temperature, you're not necessarily going to get things to cook properly. So what do they do with those higher elevations in order to get rice to cook or pasta, that kind of thing? Kind of an interesting little issue that they have. It's a big effect. It's not little. Anyway, I want you to go back and answer these questions, and then we'll go back to talking about solutions. I want you to just do a little bit of work with Table H. That is looking up the vapor pressure of propanone at 30 degrees Celsius and at 50. So there's propanone. You'll figure out what to do from there. Look at ethanoic acid's vapor pressure at 100 degrees Celsius. And then kind of a nice tie-up question is, what is ethanoic acid's boiling point at standard atmospheric pressure? So just look those up, and just as usual, you get a little bit of leeway on the graph. Probably plus or minus 2 on this axis because each box is 10. Probably plus or minus 1 or so on this axis. Oop, we're battling that again. Oh, it's okay. Anyway, probably only plus or minus 1 or so on the x-axis because each block is only 5. Anyway, so that's it for that, and we'll be ready to talk about the next part, which is freezing point depression and boiling point elevation, which will tie us into our ice cream lab, and that should be good. All right, thanks for watching.